Hello, we were back in concepts of hydraulic jump. Today, let us try to understand classification of hydraulic jump. This classification, what we have, is mainly based on the criteria of Froude's number. So let us remember once again, the Froude's number is V by square root of Gy. We also have varied versions of Froude's number. In some cases, we write this in terms of Froude's number square. Anyhow, it is based on the Froude's number, the values of Froude's number. We classify the hydraulic jumps, and you must also remember that the main intention of hydraulic jump here is to dissipate the energy. Most often, the hydraulic jump is provided on the downstream side of a dam or a weir. Okay, so the classification of hydraulic jump is based on the Froude's number, and it is also, it conveys something related to the energy dissipation. It starts from 0 percentage of energy dissipation to the extent of 85 percentage. Ideally, to say Froude's number is less than 1, or Froude's number, if it is, let's say, zero point 0.5 or zero point 0.7 or zero point 0.9, the jump is impossible. Okay, and if Froude's number is equals to 1, or if Froude's number lies between 1 to 1.7, we call it as a standing wave, or the jump is known as undular jump. Okay, uh, the undular jump is the one where Froude's number lies between 1 to 1.7. It is very weak, and the extent of energy dissipation is less than 5 percentage. Whereas we have something called weak jump, where Froude's number lies in between 1.7 to 2.5. You will have the rise with the small rollers arrangement. The surface is very smooth, and energy dissipation can be up to 15 percentage. And you can see some minor turbulences here. And probably the fourth one is the one where Froude's number lies between 2.5 to 4.5. We call it as unstable jump, and it is also known as oscillating jump. And you have an irregular pulsation, which creates large waves. Okay, and this will converge to the downstream side for a more than 1 mile length, and dissipation of energy is around 45 percentage. We're talking something related to the unstable or oscillating jump. You'll have huge oscillations. Okay, so the next one is, we call it as a stable jump, or well balanced jump, or a steady kind of a jump, where Froude's number lies in between 4.5 to 9. And this is one of the best jumps we have, and the dissipation is around 70 percentage. Okay, the stable jump. And the last one is, probably over the years we have identified this as a most efficient jump, where the energy dissipation is 85 percentage. It's a strong jump. So where you have very rough kind of a surface, turbulence will be at its maximum level, and the Froude's number is always more than 9. Okay, so we have the varied varieties of jumps here, starting from undular, weak, oscillating, stable, to the extent of strong jump. Now there is one more way to notify the hydraulic jumps, with the help of a ratio y2 to y1. The ratio y2 to y1 is huge in terms of a strong jump. Okay, whereas it's bit less or least in case of a weak jump. Oscillating, it increases, and it tries to accumulate a value of around 10 to 12 in the stable jump. Okay, now we have to ask one more question: why we have to have the hydraulic jumps? So here comes the uses of hydraulic jump. So, as we know, in most of the cases, hydraulic jump is used to dissipate or destroy the energy of water where it is not needed, and otherwise, the existence of this energy will cause damage to the hydraulic structures. What we see in the downstream side of a dam is this hydraulic jump. Uh, this hydraulic jump is intentionally induced to dissipate the energy to reduce the damages to the downstream channel sections. The second one is it may be used for mixing of certain chemicals, like in case of water treatment plants. For example, this image, it says something related to the water treatment plants where you have something called coagulation. Coagulation is mixing of chemicals for the secondary sedimentation process. Okay, and this mixing is done with the help of a jump here, and this jump will induce a flash mixing of coagulants to the existing water, and thereby you can have the sedimentation aided with coagulation. Hope you have studied this. The third one is the most important one. It may also be used as a discharge measuring device. Now the image in the middle, the second image that you can see here, this says something related to the discharge measuring device, and we call it as Venturi Flume. As students, we know Venturi meter. This device is known as Venturi Flume. Flume is a prismatic section of a channel, and the main difference between flume and channel is the area of cross section of a flume is far less than the area of cross section of a channel, open channel. Okay, now here there are three parts: inlet, the throat, and the outlet. In the throat, you induce some amount of jump here, and thereby you will form the hydraulic jump. And you calculate the discharge by using the same old discharge formula A1 into A2 into square root of 2GH divided by square root of A1 square minus A2 square, where we call H equals to the jump here. So I hope you have understood some concepts related to the hydraulic jump. The main things here are the depth of hydraulic jump, length of hydraulic jump, and energy dissipation. You can also go through the classification of hydraulic jump and some applications of hydraulic jump. Thank you.